Picture this. Invisible moisture is hitchhiking through your house right now and traveling on air currents, looking for cold surfaces where it can turn back into liquid water and cause damage. In this training, we're going to learn how to spot the pathways this moisture uses and understand what happens when it gets trapped. Most water vapor doesn't walk through your walls. It rides. It hitchhikes on air currents and is constantly moving through buildings and homes. This air-transported moisture can leak in or out of buildings through any opening, and that's where most moisture problems begin. Think of air as a moisture delivery system. The more air movement you have, the more moisture gets transported. Stop the air movement, and you've stopped most of your moisture transport. And here's a perfect example that you'll see in the field as a home inspector: leaky ductwork. When HVAC ducts leak, they're not just wasting energy, they're creating moisture problems. Leaky return ducts can suck humid air from crawl spaces and basements and then distribute it throughout the house. Supply ducts leaking into wall cavities can pump warm, humid air directly into spaces where it shouldn't be. And this is why ductwork integrity matters for moisture control. It's not just about energy efficiency. When you're on a home inspection, you're inspecting the HVAC systems and the ductwork. Think about moisture implications of what you're seeing. Remember our dew point discussion in the previous video? Here's where it gets real. As that humid air travels through a building, it's looking for surfaces that are colder than its dew point temperature. And when it finds it, boom, condensation happens. Water vapor instantly turns back into liquid water. And now you have moisture where it doesn't belong, inside wall cavities or on wood framing members, soaking into the insulation. And this is how vapor transport creates the problems you can find during home inspections. And here's what makes vapor transport kind of dangerous. When moisture gets trapped inside building assemblies with no way to dry out. Imagine the warm, humid air getting into a wall cavity, condensing on cold surfaces, but then having nowhere to go. The moisture just sits there, creating perfect conditions for mold growth and structural damage. This is why understanding vapor movement is critical. You need to identify not just where moisture might get in, but whether it can get back out or not. So let's revisit a key principle. Warm air carries more vapor than cold air. This isn't just theory. It explains why most of the condensation problems you'll encounter exist in a home inspection. When that warm, moist, laden air hits a cold surface, it's like a sponge that suddenly can't hold as much water. The excess moisture has to go somewhere, and that somewhere is usually onto building materials that weren't designed to get wet at all. Understanding vapor transport helps you make sense of what you're seeing during inspections. So if you're looking around and you spot water stains, mold growth, deteriorated materials, you can work backwards to figure out the moisture source. Is there an air pathway that could be delivering humid air to this location? Is there a temperature difference that would cause condensation? Are there building assembly details that could trap moisture once it arrives? This understanding also helps you evaluate vapor diffusion retarders when you can see them. A vapor retarder's job is to slow down moisture movement through diffusion. But remember, most moisture moves through air, with air, not through diffusion. If you see a vapor retarder that's installed incorrectly or damaged, you can assess whether that's likely to cause problems based on your understanding of how moisture actually moves in that specific building. Every moisture problem tells a story about air movement and temperature differences. You master these concepts, and you'll be able to read that story and explain it clearly to your clients.